arrangement yet. Assalamualaikum, salam Jumaat, salam Madani, salam UTM Sanjangan Bangsa. Hari ini kita bersama In Conversation secara live. Pertama kali kami buat live. Biasanya kami record dan kami post di Facebook dan YouTube sebenarnya dan boleh access through Facebook. Tapi hari ini kita special. Kita ada guest yang special juga yang bincang bersama dia yang special. Hari ini semua special. Saya perkenalkan dulu guest kita iaitu Dr. Yap Yung Shen daripada Faculty Science Universiti Teknologi Malaysia. Welcome to In Conversation, Dr. Yap. Episod pertama dibuat live. Wah, betul-betul special ni kami buat untuk Dr. Yap.
Right,
welcome to the show.
Good to be here. Thank you.
Yeah. So basically Dr. Yap daripada Faculty Science dah berapa tahun dah?
So saya join since 2008.
2008.
So has been quite a while juga lah.
Yeah. Season juga tapi nampak muda you.
Don't be fooled.
Don't be fooled by the appearance. Dr. Yap ni for the information, for the audience information, dia ialah saintis dalam bidang quantum technology di UTM ni. Bila kita bincang pasal quantum technology ni, saya fikir even di Malaysia, ni saya claim, saya suka claim untuk UTM ni. Saya claim dia nak kata a handful tu agaknya entah the only yang actively researching in quantum technology. Boleh tak buat claim itu?
So
nak kata terulung kan macam melampau sangat. Tapi
so there are colleagues from other universities, but they are studying on different parts of quantum technology. But when it comes to hardware, building a quantum computer, unfortunately, I'm the only one.
So basically, you are your field of area is quantum computing lah.
Quantum computing.
So before we go into quantum computing, explain to me, ni orang layman yang tak tahu technical, because my field is business marketing, tak ada kena-mengena langsung dengan physics ni. Although dulu masa sekolah ambil lah physics kan. But if you can simply explain what is quantum technology.
Right. So quantum itself is a branch under physics, and you have classical physics, you have quantum physics, and under quantum sebenarnya ada banyak sub topics lah. But one of it is quantum technology. So quantum technology is not atas; it's actually bawah quantum itself. And the effects that happen in the classical world and the quantum world are very different. So baru-baru ni tahun ni ada Nobel prize in physics, and one of the example is kalau you baling bola kat dinding, in the classical world dia pantun balik.
But every action there is a reaction.
Right, you know, like lah. Still remember your physics.
Mesti cikgu I panggil. Tahu juga ada ni.
But in quantum there is a non-zero probability that dia boleh tembus. So you baling tu dia tak pantau balik, dia goes through. And it's not like hearsay, rumor or something, but it's an actual physical
Proven.
process. Yes.
It's proven.
Yeah.
Okay. I ada baca sikit. Dia kata one of the simple definition is like the physics of the very small.
True.
The physics of the very small.
True.
So you are basically studying the atomic level lah.
Correct. So typically the quantum mechanics effect dia muncul cuma bila you go to very small numbers. So it could be size. So you go down to millimeter, nanometers. And I mean, the smaller you go, then you start to see this effect. You can also see these effects if you go to, for example, temperatures. So you go down to like minus 273 Celsius, which is near 0 Kelvin, then you start to see very strange effects. So those are quantum mechanic effects.
Quantum mechanic effect.
Right.
So because let's say macam to simply understand this, I'm trying to understand this at the very basic level. The ball tadi kan, reaction, the ball baling. So dalam the smallest effects, so basically kalau kita kaji into deep, very atomic level, nucleus, whatever tu, basically kita akan nampak the glitch. So itu yang you study, the glitch tu.
So for quantum technology specifically, we use something that is called qubits.
Qubit, yeah.
And these qubits have some properties that we can actually use for information processing. So the example that I like to give is you have a box. So box tu kosong, atau if you masukkan a bola in the box, so it's either kosong or ada bola lah. That's the classical world. In the quantum world, the ball is inside and kosong at the same time.
Okay.
Right. Well, you accepted that very, very fast. So it's kosong, yet there's a ball at the same time, and that's what we call a superposition state.
Yeah, superposition. Okay.
Exactly. So
okay, hold on. Nanti sebelum I pening. Superposition. Kalau spinning coin.
Right.
Spinning coin. Analogy dia.
Correct.
So if you toss the coin, either head or tail.
Correct.
But this superposition, the coin is spinning. It can be both at the same time.
So the coin is spinning, and when it's spinning, you don't know what's the result.
The result.
But when you measure it and you open and you have a look, then it shows you either 0 or 1.
Yeah.
But when you don't, it's both at the same time.
Okay.
So the classical physics, the classical computers, they cannot do that.
So the classical computer 0101
Bits.
So this is qubit.
This is qubits.
Okay.
And what you can do, like just now you said there's some sort of connection or something. So let's say you have 2 boxes and you have 1 ball. So if you tutup them and the ball could be in either one, you don't know where is it. Lepas tu buka satu and you see, oh, ada bola. So confirm yang satu lagi tu tak ada bola. You know for a fact. And that's the classical world. But you also see something similar in the quantum realm. So the qubits actually, you can have 2 qubits and they are entangled. And if you measure one, instantly you know what is the other one. It doesn't make sense.
Okay, macam magic ni. Macam magic ni.
And it can be anywhere, not just, it can be as far as from our universe to another, our galaxy to another galaxy.
It's not just location.
Yeah, there's something happening between them. It's a physical process. They show that it's actually physical. Lepas tu kalau you ukur, you find out once the state of one qubit, you instantly know what is the other.
This superposition.
Correct.
Entanglement?
No, that's actually entanglement. So entanglement when you have 2 qubits entangled together.
Yeah.
Superposition is yang satu kotak tu ada dua
state
at the same time. Right.
So that is the basics, the basic understanding. So the application of it, of this so-called the basic theory or law or rules, look at superposition, entanglement. So the application, quantum computing, sensing,
correct,
and then
communication.
So you are into the
quantum computers,
computing. So how does it apply these rules to this quantum computing to have these quantum computers?
Right. So the quantum computers, they use the qubits to store information and to process them. And because you can have these superposition states, you can actually store a lot of information and process them much more in parallel compared to classical.
Okay.
So classical, kalau kita nak jadikan parallel, kena tambah hardware.
So di satu path, classical satu path. Okay.
So you kena tambah satu lagi hardware, then baru dia jadi parallel. You have to tambah another whole new one. Makin lama makin besar, makin panas and whatnot, right? So, but quantum computers, you don't add a whole new hardware, you just add a qubit. So by adding one qubit, it becomes
How big is one qubit though?
So it's actually very small.
Kalau compared to yang
right.
bit
So
tu?
if compared to, it's actually bigger than normal electronics, the size. So normal electronics sekarang, if you are tech, into tech and everything, the nanometers, how many nanometers, 9 nanometers, those Intel chips or whatever. For quantum qubits on the superconducting one, they can be as big as a few hundred nanometers. So on the quantum world, that's actually very big. It's called macroscopic big lah. So normally you tak nampak that. And you use that to form qubits, and you can have a lot of information stored, and you can process them. And by using these qubits to detect, nak ukur something, suhu ke, magnetic ke, then it becomes quantum sensors.
This is maybe not a very high-end question, but
No.
let's say now the speed of internet tu,
Betul, okay.
100 megabit per second.
Okay.
Itu pun dah laju 100 megabit per second. Sekarang cakap even the service provider is offering 1 gigabit per second. 1 gigabit per second. So kalau in terms of quantum tu,
So,
so 1 bit equals to what? A qubit punya. Is that comparable or what?
No, it's not comparable. So if you increase the number of
Qubits,
bits, katakan ada 1 bit ke, ada sejuta bit ke, because it's classical, dia hanya boleh ambil satu value saja.
Okay.
So if you have 3 bits, it's like 101. That's all.
That's all.
But if 3 qubits, you can have all the 000, 001, all the value at the same time.
Okay. So
So
this is crazy.
Yeah.
So I was just imagining now AI, kita cakap pasal AI, develop AI, new AI. Dulu ChatGPT je, sekarang ada itulah inilah yang China punya apa DeepSeek and everything. So they are using supercomputer
Correct.
to
Classical.
be the engine of the AI. Still classical.
Still classical.
So what happens if we use quantum computers to be the engine of AI? Would the AI be like super duper fast or very large, rich or whatever for the knowledge or whatever?
Right.
That kind of thing?
So current quantum computers are not at that level yet. So what I normally say is that classical is at this level now.
Okay.
And quantum is doing a catch-up game.
Okay.
And the moment quantum can catch up, then it will most likely replace classical computers. And it is much faster, and you can actually use it for AI. So there is actually a field within quantum computing, which is called quantum AI or quantum machine learning, QML.
Yeah, quantum machine learning.
There is
So basically, this is the future.
Yes, it's the theory is actually sound. It's just that the hardware is not here yet.
Okay.
So, for example, if we know the high-speed rail, and I'm from but this, I would love to have the high-speed rail daripada Johor.
December coming.
So we know the speed is like how many 400 kilometers a jam. So daripada sini pergi KL sejam. The theory is sound. You know the theory. But the hardware is not here.
The train is not here yet.
The train is not here. So that's the situation of quantum computers. We have quantum computers.
How far are we from getting the? Maybe not for everyday use by consumers like me, but at least for scientists or tech companies or universities.
Right.
Like maybe if I can give you an analogy, back then in the 70s or even the 60s, they have a computer, but the computer is like the size of this room.
Correct.
The CPU is the size of this room.
Correct.
And then we have like smaller CPU, and then we have a tablet now, whatever, whatnot. Right. So how long are we going to get there?
All right. So quantum computers are not meant to replace our PCs, our normal PCs. They are meant to be the next generation of supercomputers.
Okay.
So they will still fill up a room.
Still, yeah.
I won't be able to carry it around.
Yeah.
But at which stage does it become that? There's a lot of prediction. And some say 5 years, some say...
Oh, not that far.
So it could be between 5
but
to 10.
But because, of course, sometimes the technology is there, but the willingness of the business to venture into the technology and make it commercial.
Correct.
Yeah, there is another story. Yeah.
Correct. So because there is no fixed number, it could be between 5, 10, and 15. But sometimes 5 to 10 is actually not too far as well. So having that time frame means that if we want to do something to implement on the national level, it takes time. It doesn't take 1 year to implement something. So maybe, for example, you have to implement quantum communication.
Yeah.
By the time you revamp the whole system, dah ambil masa 5 tahun dah.
Yeah.
So quantum computers you can buy now. You got about 20-30 million. You can USD. you can get a very good quantum computer.
Yeah.
It's not as powerful as classical, but you can actually do something with it, which is called hybrid computers.
Okay.
You combine the best of both worlds.
So the bit and qubit running at the same time?
Not at the same time, but they take turn. So they calculate sikit kat classical, they hantar kat quantum computer calculate.
Because the way I see it, if we are looking at the traditional ones, I go into the library. This is supercomputer, obviously. I go into the library. Instantly, I can read one book, finish. Like, for instance, laju ke apa.
Okay.
But for quantum, I go into the library, the whole library I read.
Correct. So that would be one way to say it, or another way, if you want to go through a maze.
Oh yeah, the path
you have to go cuba satu-satu. But in quantum, it just fills up the whole maze terus, and you cari the exit terus.
Yeah, but because of the speed, because the supercomputers are now at a very advanced level. Because of the speed, even one path, they can still get the information quite fast, quite quickly.
Yes.
So what is the benefit of going through all the paths in the maze when you can get the same, or more or less the same time? Or this going to get quicker or faster, the quantum?
So it really depends on the problem that you're trying to solve. So the size of the problem, if it's small, then you don't see that much.
Yeah.
But when the problems become bigger, so for example, you want to design new drugs.
Yeah,
you want to design how molecule interacts.
Yeah.
The nature of it is quantum. Jadi kalau guna classical nak calculate quantum, you have to buat a lot of assumptions, a lot of estimations, and then you have to do approximations, buang ni, buang tu, and that is just to speed it up.
You're cutting corners.
You're cutting corners. But on the quantum computer, you don't need to cut corners. You can do it much faster and more accurately than a classical computer.
So what are your study really going into right now for your own personal study on quantum computing?
So for me, I actually built the control system for quantum computers in Singapore.
Yeah. Oh, the lab is in Singapore.
Yes, the lab.
So you're part of a bigger research group, or?
Yes. So we do not have quantum computers here. I do have a small setup in UTM. But for the full scale one, I work together in Singapore.
In Singapore.
And also I'm doing some work with Japan as well.
So for this region, for Southeast Asian region, only in Singapore we have this facility.
So within the Southeast Asian region, yes, Singapore is quite at the forefront. Yeah. They have the Center for Quantum Technologies. That's where I'm attached.
Center for Quantum Technologies.
Right.
So the only center on that level in Southeast Asia.
Correct. So they started back in year 2000 actually.
Okay, wow, quite far. 25 years ago.
Correct.
So which brings me to the next question for you. So that is why we are having the ASEAN Summit in UTM later.
ASEAN Quantum Summit.
ASEAN Quantum Summit in December 10. Yeah, and from 10 until 12.
Correct.
So this is ASEAN Quantum Summit. So you will be leading this ASEAN Quantum Summit. Can you explain a little bit on this ASEAN Quantum Summit?
So it's the first ever quantum summit in ASEAN, and we got a special approval for it, and we are going to have a lot of experts in different fields. So just now we talked about the three fields: quantum computing, communication, sensing. There's also quantum metrology. There's also quantum biology. There's also the policies and strategies. We are bringing all the experts under one roof in one event.
For the first time ever in ASEAN.
For the first time ever in ASEAN. And it's a very good platform to come and learn, to come and find out what is quantum technology all about.
But the discussion during the summit will be advanced level discussion, all the parallel sessions, or people like me can come and can still appreciate what is being discussed?
So the idea is for this summit is on the awareness level.
Awareness.
So we will have a lot of people who are registering for the first time to just find out what it is about, and that's the whole idea. So we have sessions which are for registered participants on the first day and the second day, and we also have public events on the second day during the officiation, and that will also be for anyone who wants to learn more about.
Yeah, everybody is welcome basically from the second day onwards, correct?
Yes, from the second day, the officiation dalam jam 2:30 petang sampai pukul what is. We have Malaysia has the National AI Office, NAIO. Singapore has the National Quantum Office. So the executive director of NQO
will be here
to give a plenary, and also the director of the Quantum Information and Quantum Biology Center in Osaka University
will be here
for the plenary. So these are two exciting talks.
When we say ASEAN just now, so how many countries basically have this expertise or currently pursuing study, research on quantum technology? Malaysia, definitely with you.
So
and Singapore.
Singapore is at the forefront in Southeast Asia. Thailand, diorang dah produce batch pertama PhD dia. In hardware building. So in Malaysia, we don't have students building hardware yet. So we are at least 5 years behind Thailand, right? I would say that's about it. But we also have people doing theory from Vietnam, Indonesia, Philippines.
But basically because of the awareness.
Right. So
it is not a new. Of course, the buzzword now is AI.
But the next buzzword coming is most likely quantum. And for Malaysia, we are going to come up with a policy. Yang Amat Mohamad, Prime Minister, has announced it in the Med4IR, and so that will most likely be the next buzzword.
Quantum technology. How do you see for yourself? Like, how are we going to promote this quantum technology to our future students of UTM, for example? What would you say? What would you would like to say to attract all these students, not just from Malaysia but from abroad as well?
Right. Doing quantum experiments, all the for me the hardware.
Because AI is not to say simple. AI is easier now because the generative AI, people are using the applications on a daily basis now, and people are making policies at schools on how to use AI for your thesis, whatnot.
Correct.
So people can see the application right away. But for quantum, maybe it is underlying all these applications. So how do you spread the awareness? Of course, with the summit and everything. But
So one of the best way to spread awareness is to go around and give talks about this. And I have been doing that quite often since last year. So on average per month, I give 2 to 3 talks on quantum.
To what audience? What kind of audience?
Various, ranging from schools to agencies to governments, ministries. And the idea is all of us are curious about it. And we want to learn, nak belajar macam mana berfungsi, what's the excitement about, and makin lama there's more people interested with it, and also what are the risks involved with it, and what are the benefits and the impact. So because of that, I think it's important to actually do this kind of talks and
because I remember in the late 80s, I think I talked to you just now. I mentioned to you earlier before the start of our conversation. There was a TV series called Quantum Leap. That's why the title of the episode for today is Quantum Leap, Why It Matters to You. Starring Scott Bakula. I remember the actor's name, Scott Bakula. It was very famous in the late 80s, and it won several awards, like Golden Globe, prestigious awards in Hollywood. But I'm not sure whether it has the same fundamental, because these writers, when they wrote the story, they studied a bit, but they gave the title of the series a Quantum Leap. But basically, he's like moving from one body to another. He developed a supercomputer or whatever. Then he did an experiment, so he kind of leaped into other realm. So how far are we from that? Because I want to ask you whether we can do such approach. We do maybe TV series, movies. Maybe the government can help you to develop a TV series, doing on this kind of thing, so people can actually be interested in quantum technology.
All right. I hate to burst your bubble, but that's not quantum.
That's not just the quantum. That's just time travel.
Yeah.
Time travel, science fiction.
Yep. Yeah. But if you are a Marvel fan, then there's the Ant-Man.
Okay.
And the Ant-Man at some point dia jadi makin kecil, until it goes to the macroscopic the quantum realm.
Yeah.
And then dia jumpa tardigrade ke apa ke. To some, not about there's a whole new universe there, but at the quantum level, there's a lot of strange thing going on. So it is interesting.
So that's why maybe you should have a different. Of course, giving talks is important. You go to the policymakers, to scientists, and you give talks to future students or potential students. But maybe you should collab with a writer and do a science fiction movie, but still with the very strong fundamental of the theory of the quantum technology. I think that should be the approach of UTM. The corporate communication team, this photo and video team, they should do something on this one.
Well,
is that possible? Is that possible, right? It's possible.
Yeah, if we are coming up with a movie team with quantum, then I can give some points.
Give some points. So let's go back to this ASEAN Quantum Summit. So it will be 3 days.
It will be 3 days.
From the 10th until the 12th of December, which is like a week or so from now, maybe 10 days from now.
Correct.
Yeah. Can you spill on who's the VIP? You just mentioned the director of the from Singapore and National Quantum and from Osaka.
Yeah.
Is there a possible VIP from Malaysia?
So there is. So we have invited a few ministers to attend.
Yeah.
These are related because it's an infrastructure that quantum technology is an infrastructure that crosses a lot of ministries.
Yes.
And we work very closely with, of course, KPT, then Kementerian Digital, and then MOSTI, and also we are working very closely with the Johor state government as well.
Yeah.
And yes, so we are expecting some VVIPs.
But nothing is confirmed. Hopefully, it's in the process. It's in the pipeline. It's in the pipeline. It's just to give the audience a picture of how it is a big summit. It is a big summit. It's an international summit, and
so we have about around 40 to 50 delegates from ASEAN. There will be about 20 delegates from 25 delegates from Japan. Yeah. And we have speakers, a few speakers from all the way from Europe, and then from the Open Quantum Institute by JESTA and CERN. So CERN, the big physics particle accelerator.
Will there be exhibitions during the summit?
Yes. So we actually, one of the idea is to bring in companies and quantum companies to give talks, and also there's exhibitions. They will display their products.
Okay.
And then we will also have a lot of forums to discuss on different parts. There's actually meetings as well to have sort of like an action plan or a recommendation of what ASEAN can do for quantum technology. So many things installed.
Yeah. So we are nearing to the end of our session now. To wrap this up, what is your thought and what is your hope for quantum technology, especially for your team and for UTM?
Right. So what I actually really hope for is to have an industry in quantum technology in Malaysia, because from our department we can try to produce graduates in quantum technology, but kalau tak ada industry,
where do they go?
Right? Then ada masalah brain drain and all that.
Yes.
So one of the things that I've been proposing strongly is to have the Malaysia Quantum Valley here in Johor, under the Special Economic Zone.
Yeah.
And quantum technology has already been approved as one of the sectors to benefit from tax exemption in the JSSCZ. And working together with our neighbor Singapore, they have a whole established quantum ecosystem. And having the Quantum Valley here is a good way to work with our neighbor and to bring it up. So that's my dream.
Yeah. So you have to come to UTM on the 10th of December. DSI, the Dewan Sultan Iskandar, the main hall will be the Dewan Sultan Iskandar, but we have parallel sessions.
Yes.
But of course you can go into, do you have a website for it or?
Yes, so we have a community called the Malaysia Quantum Information Initiative, MyQI. So just log into www.myqi.my. And you can find out a lot of information there and register through there. Time is short.
Do it now.
Do it now.
Yeah.
And I hope to see you there.
Yeah. So thank you for your time. I know you're a very busy person with your research and everything. On top of that, you have this summit going on, all the things that you have to do for the summit. So thank you for your time, and I wish you a very good summit to have.
Thank you.
Come December, and thank you for your time, and hope to see you again.
Hope to see you again. Thank you.
So, bye-bye.
Thank you.
Oh, how do you feel?